Hello everyone and welcome to our webinar. Today we'll be covering the second installment in our Aerospace and Defense webinar series. My colleague Tim Haythorne, Business Segment Manager of Aerospace and Defense in the UK, as well as Pritesh Modi, Technical Consultant here at Eggplant, will be covering briefly what we talked about on our previous webinar, as well as diving into a demonstration of what automation intelligence looks like in action, specifically in the aerospace and defense industry. And now, without further ado, over to Tim.
My name is Tim Haythorne, and alongside my colleague Modi, today I'll be demonstrating how Eggplant's automation intelligence solution can support A&D software teams, showing a worked example on an industry-specific solution. During the first session, Jim highlighted 6 key strengths of the automation intelligence solution that can be leveraged by A&D software teams. The first was testing in terms of real user journeys and ensuring that criteria tested is directly linked to desired mission outcomes. At Eggplant, we know only too well that our customers are often supporting complicated systems. And it's often said that builders don't test it and testers don't build it. And the gap often formed between these two business functions is often expanded by system complexity. A model-based testing approach can help bridge this gap. It's effectively an agreement between dev and test teams about what has been built and what needs to be tested, and this helps adoption of practices like DevOps and Agile within software teams, breaking away from the traditional linear regression packs. As the AI model is built, all crucial and possible user interaction can be mapped, and leveraging powerful decision-making algorithms and machine learning, test scripts can be automatically created. The ultimate goal of this approach is to achieve great test coverage by identifying all possible user journeys, thereby reducing the risk of software failure once deployed. Here, Eggplant AI effectively accounts for the unpredictable user. Now, real user journeys are powerful, but they need to be in a real environment. Long-time listeners will know that this has also been addressed by Eggplant's solution. Now, it's really important that when running test scripts to ensure that results are meaningful, that they are executed in a realistic environment. Our customers say that they often struggle to emulate real user conditions, which may see an operator under stress battling against difficult conditions. The application itself is subject to several factors. It may be varying network conditions. It could be a user under stress, behaving unpredictably on the interface itself, or there may be multiple users all running at the same time, putting the front and back end under considerable load. To bring the real user experience to the test lab, Eggplant has created several products such as Eggplant Network, Eggplant Functional, and Eggplant Performance to help test real user conditions. Each part of the solution integrates with the next, and then leveraging Eggplant AI, the tester can bring total test coverage into a real-world environment, ensuring the user under stress is no longer operating against an untested scenario. Now, of course, we recognize that when simulating real-world environments, it's important to do so in a secure fashion, and this has always been a high priority for our development teams. This is often a challenge for our customers, where distributed systems are all supporting different variants of hardware, and using traditional tools, they've found it really tough to firstly connect with such systems, but then to operate on them in a non-invasive manner. You'll see using Eggplant's execution tool, Eggplant Functional, that the approach is quite clear in the demonstration. You'll see the operator acting as a real user, simulating real actions on real systems to test the end user experience. Unlike traditional testing tools, Eggplant can, but does not need to hook into application code. Another big gap that Jim spoke about in the first session was testing systems in isolation, and this is something that testing teams can often fall foul of as well. Now, on the right-hand side here, you'll see the automation intelligence solution, and it may create a specific user journey, beginning at an assigned starting point and finishing at a realistic endpoint. Traditional testing approaches may be limited to testing sub-functions or individual applications in isolation, but AI is able to encapsulate all integrated systems into one set of tests, bringing distributed systems under one model. All the while, important data like timestamps can be recorded to measure system performance when running in an integrated environment, and this helps identify where API or integration weaknesses may be negatively affecting real user experience. We've also talked about the test build and execution process. Of course, presenting the results, pass or fail, is important, but what do we do with that information and how can we go a step further? As the AI model runs, it accumulates execution test result data, which is converted into release analytics data to give a real-time estimation of risk around forthcoming releases. Release versions are ranked against criteria such as bug content and UX performance, and these ratings will give a quick snapshot indication of risk. This encapsulates a shift right instead of a shift left, where previously a very manual approach in data analysis is made easy, quick and shareable across the business. And this brings together more and more stakeholders that would previously have not found test data accessible. Now, we understand that it's critical to gather test results in pre-deployment testing to minimize risk when live, but testing does not end there. Eggplant is now incorporating monitoring technology to take data from live environments where possible and using this data to enhance the test process. Jim used the phrase closing the loop on mission progress, and this is spot on. Eggplant is implementing monitoring technology for thick and thin clients to bring more information from the live environment into the test process, ultimately influencing the way the application is tested. The model you have built for testing in pre-deployment can be influenced by real user activity to ensure that the user journeys tested are as close to user behavior as possible. We strongly believe that too much information is lost in regular test processes, but Eggplant is here to equip you with the technology you need to take back control. And before Pritesh demonstrates how these key strengths have been reflected in our solution, I'd like to quickly tell you a little bit more about the target system he's using and Eggplant's work in that space. Some of you may have read this year's publication around how NASA are leveraging Eggplant's technology to automate testing of glass cockpits within the Orion spacecraft. We love to work with such exciting logos, but we're even more pleased to know that our solution is being used to assure such critical technology. Following several customer meetings, we identified that NASA's Whirlwind GIS application as a commonly used product across defense and aerospace customers. So we thought it would work as a good example of how to apply automation intelligence. I'm going to hand over to Pritesh now, who will walk you through that exercise from start to finish.
Thank you, Tim, and welcome to you all for joining the webinar today. My name is Pritesh, and I will be demoing our DAI solution against the NASA Whirlwind application. To start, let me walk you through what you can see on the screen. To the left, we have Eggplant AI, and you can use this solution to create models of your application. And in this demo, we have modeled the NASA Whirlwind application. And to the right is our viewer window, part of our Fusion engine, Eggplant Functional. As we've already created a model, let's click play to see what happens. Eggplant AI's modeling interface uses states and actions to represent the digital twin of the application. Here you can see the states are depicted in blues and greens, whereby the green is the start state and the blue states are the different pages or different representations of the application under test. The grey rectangular and oval shapes are called actions. Actions are things a user can do within the application. The actions are available at the state level, which are in the blues and greens, where you can see the action points within there. And they are also available at a global level, whereby the application can be exited by this close app feature or button at any point in time. As you can see, while I've been talking, Eggplant AI has been running several test cases using its auto test creation feature. By testing in this manner, Eggplant AI is able to test every single permutation of the model. Each time, Eggplant AI will start the test case at the green state and end when the action hits an exit event. So how do we create a model? What I'd like to do first is let's go ahead and increase the model surface area itself, and let's go ahead and open up a model, something that I've created previously, a blank template. Okay, when you go ahead and create a brand new model, this is what you'll be confronted with. You'll have by and large a blank screen in front of you, a drawing panel where you've got the ability to go ahead and draw your states and actions, and a little green box which will show you or symbolize that you can actually start with this particular box here. Now, because a green state is symbolizing where Eggplant AI will start running, what we want to do is we want to say add an action here. Now the action here is going to be, say for example, opening up the application. And if we expose the right hand side menu options, this is basically your configuration panel where you're able to configure the rules and the logic and the variables of your model itself. So to start with, let's rename this action that we've just created to open app. Now this could be open a browser, it could be open something else, but this is a local demo that we're creating just so you can see how easy it is to go ahead and create your model itself. So the next thing what we want to do is we want to go ahead and add a state. Now within this state we're going to call this the login page. Okay, and inside the login page what we're going to do is we're going to add new actions. So let's just go ahead and do exactly that. The three actions that I'm going to write in are going to be username, so the ability to add the username to the text box, for example, and say, for example, with a username you need a password. And then the last thing would be to click on the login button. Okay, login button. Okay, so here we can reposition them and we can put them here accordingly. Now after logging in, we want to go ahead and access another state. Oh, sorry, that's me putting an action in. Let's delete that. Add the state in, and this state could be a dashboard, for example. And inside here we could say, for example, have a new action, and that could be, say, go back. And if we set the type to previous, what we can do is Eggplant AI will know that it will go back, for example. Okay, and we could also go ahead and say have a logout script as well, or action. We'd go ahead and apply a logout action, for example. So now what we can do is we can actually, now that we've got our small little demo in place, we can actually just go ahead and say, right, connect all these things up. And we do this by selecting on the action itself and then applying, in the configurations panel where it needs to go to after you've performed the action. So once we've performed the action, we want to go to the login screen. And again, the login button, we want to then go to the dashboard. Now, because we've already got a back button and Eggplant AI is able to discern that it's going to go to the previous, we don't need to return an adjoining path from the back button back to the login screen. In addition to this, we want to also exit the application as well. So what we can do is we can click on an action, apply an exit parameter, and you can see here that instantly, as soon as we've ticked it, it appears underneath here. So once the actions have performed for this particular action, it will then exit the application. Okay. So now you can see we've already gone ahead and created a small button, and we could actually go ahead and start to write this. We could actually go and start to run this here. So if I click run, you can see that this is actually going to go ahead and run itself, clean up as it goes along when it hits the exit state. Okay, and we could run this many different times as well. So if I set that to 0, we can then go ahead and run this many different times and it'll be perfectly fine. But we can also apply some logic to this as well. Okay, so the logic here could be that we want to say, well, okay, we want to apply the username first because there might be some, you might be able to have on your screen that you can only apply the username first, then the password, then the login button itself. Okay, really guiding the user. So to do that, we can actually add sequence of events as well. So for example, if I click on the action button for login, I can set that to a sequence event. You can see that it turns into an oval. And the same can be applied to the password field. Okay. Now once we've done this, we can actually turn around and say, right, okay, let's go ahead and interlink these actions together. So from username, I want to now click on password. And from password, I want to go ahead and click on the login button. So here we have an interlinked sequence of events. So if I double tap that, you can see that there are arrow lines going from the username, through to the login button itself. And we can go ahead and run this again. So we can actually test the model without actually writing any kind of snippets of code that would typically be attached. Okay. So let's go ahead and stop that run. So how do we go ahead and attach the snippets of code? So if I go ahead and minimize this panel here, what I can do is I can bring into the event the snippets of code. So let's go ahead and bring this here. Now on the left hand side we have a couple of tabs. One is the model tree. You can see here we have the exit state, and you can see I've already applied the exit state to one of the actual actions on the screen itself, in the model itself. And this basically says to AI, once you hit this action, exit and end the test. We have a couple of others such as cleanup. So upon exception, go ahead and apply the cleanup capability, or indeed just apply the cleanup capability once it's ended the test. So there might be a separate cleanup process to the exit process. And then on exception, we have the error handling capability here. So when an action takes place and an error occurs, such as inconsistent behavior, for example, it will then, upon error, it can also reset the device back to its original settings, and then go ahead and continue with the rest of the tests. But let's look at how we can actually go ahead and apply the snippets of code. So here you can see we have snippets of code already. And what we're going to do is we're just going to apply these. Now these snippets of code came from Eggplant Functional. So this is the Fusion engine that we spoke of earlier. And what I'll do is I'll show you what the Eggplant Functional looks like in a few short moments. But rest aside, we've got some Eggplant Functional code here that we want to attach to our snippets of code. So all we need to do to enable this is to click on the action itself, right click on the snippet of code we want to attach, and add to the selected snippet of code. And then we just repeat the process. So here we want to apply the username, here we want to apply the password, and here we want to apply the login button. Now again, what we can also do is we can actually apply variables. So now that we've attached the snippets of code, you can see that it's highlighted in green at the top left hand side of each action. You can also apply snippets of code to the states as well to make sure that you are on the correct state. What we can then do is we can actually start adding our variables. So for example, the username and password, we need to go ahead and apply our variables. So how can we do that? So we can actually set global variables, which you can see here. And we can also set our user or action variables, which reside here. And we can also set up state variables, which you can see here. So let's go ahead and apply state variables. Okay, we're going to apply two. The first, as you can probably imagine, is going to be username. And we're going to set that to text. And we are going to keep that as non-generated. And we're going to do the same with password. So let's just go ahead and grab our second variable. Click OK. Now there are a couple of other variables that we also want to pass in. In actual fact, we want to create one more variable, and that's going to be the label. Okay. Now the label could be the tag on the screen as to what the username represents. So it's a username and then next to it is a tag field. So here we can just call this label as the variable, and we're going to pass in some text. Okay. Click OK. In actual fact, we're going to rename the variable for username. In fact, it's going to be an actual username that we want to put in. So username data, make it more meaningful. Text. Okay. So now that we've created our state variables, what we now need to do is we now need to apply them to the individual actions on the screen. So let's go ahead and do exactly that. So username. So what we can do is we can just add these here within the snippets called by action. Okay, so what we want to do is we want to pass in the label, and we also want to pass in the user data. Okay, so click OK, and what we can do is we can actually set this information within the configuration panel itself. So first off, the label is going to be, for example, set to say username, and the password can be and the username data can be, say, pmodi at so the username data can be set to say pmodi at gmail.com, for example. So now what's going to happen is when the information is passed, that's actually going to get sent via this particular element here to the actual snippet of code. And that snippet of code is going to handle that process, write the information onto the application, and then perform its actions and see what the outcome is and whether it conforms to what it's asked for. So let's do the same with password here. So we want to pass in the label, and what we want to do is we want to say set the label to password field now. Notice I'm using the same variable, but I'm now changing the value of that variable as well. And the password element, I'm just going to go ahead and set to test02, for example. Okay, and this is then obviously going to be tied in to the snippet of code. So here, let's just go ahead and add these two. Now, we can specify the order of the actual labels themselves as well. So here, as I said, I'm going to push the order of variables across where label is the first thing that's passed and then password is the second thing. And click OK. And there you have it. So it's a very, very simple way to go ahead and apply logic to your application. You can see very quickly we've gone ahead and built the actual model itself, and of course tied it to some snippets of code. But for those of you who've never touched Eggplant Functional before, well, how can we go ahead and build our snippets of code? So let's go ahead and do exactly that. So for those of you who know Eggplant Functional, you know that this is we work on a two-system model approach whereby you remote connect into a machine, and then anything you write in here in your snippets of code, you'll be able to then drive the system under test that you can see in the top right-hand side. Okay. Now, the language that we utilize is SenseTalk, and typically it is a language that uses common phrases to go ahead and perform actions on the screen. So, for example, if I was to type in the word click and then specify the image between quotation marks, I'll be able to go ahead and click on a particular image. if I was to say, for example, then prefix this with text, then it will start using the OCR engine to go ahead and perform text searches on the UI elements of the system under test. Okay. Equally, if I wanted to wait for something to appear, I could simply type in the word wait for, specify a maximum wait time, and then again apply the image reference in the syntax, or indeed if I was looking for some text, then I could go ahead and prefix this with text. Now this is quite simple, but you can do more complex things, such as you can apply conditional statements as well as repeat loops as well, and apply arrays, create variables and apply them into your code itself. Now, say for example you've never picked up eggplant functional before. Well, again, it's really easy because you can actually utilize the viewer window to actually write your code. So if I was to create a 3 or 4 step script, I could simply go ahead and utilize the viewer window to capture all my images. So let's show you how we can actually do that. First off, in the viewer window, we have, if I just expand that ever so slightly, we have a live mode, which you can see we're currently in right now, where I can take control over the system under test and perform whatever actions to prepare my environment. We also then have capture mode that enables us to capture the images. So let's go ahead and zoom in and grab an image. So the first image being the Chrome button, and what I'm going to do is I'm going to use the click action to perform to record the actual information that I'm trying to capture. So first thing here that it allows me to do is to actually capture the image. I'll call this Chrome, click save, and when doing so, after I click save, you can see that the image appears within the image repository. The code is automatically written within my snippet of code, and then here, if I zoom out ever so slightly, switch over into live mode, you can see that the actual Chrome browser has automatically started to load. So I can actually continue with my script. So let's go ahead and do exactly that. So the first thing here that I want to do is I want to go ahead and capture the refresh button. And all I want to do is I want to wait for that particular item to be present. Okay, so here we'll call this refresh. Okay, and what we want to do here is we want to apply maximum wait time. Instead of 8 seconds, we're going to apply 20 seconds. Okay, so what will happen here is that it will wait for up to 20 seconds. It won't wait for a static amount of time. It will actually run the test to see, do I find the refresh button? If I found the refresh button, terminate the timer and move on to the next line of code. So click save. And you can see that's automatically added and the image also applied. So the next thing what I want to do is I want to grab an image as a reference. So I can grab this search box here, grab it as a reference, and I can actually move my action events. So that's the little hotspot that's typically in the middle of the image. Wherever I draw, as you can see, I can actually go ahead and move that hotspot to say, right, look for this magnifying glass image, but I want you to click over here. So again, what we're going to do is we're going to use the click event to go ahead and perform this action. Click save. And then what we're going to do is we're going to apply the type text parameter to type some text in. So here what we can do is we can apply, say, a web address, IO for example, and then at the end of this we can actually add a carriage return. Whenever you're typing text, it is where you're actually hitting the keyboard, and that's what we're instructing eggplant functional to actually do. So here you can see the syntax has been written and it's actually performing the test here as well. So here you can see it's found the website, and now all we're going to do is we're going to go ahead and find this particular logo here, and all we're going to do is we're going to perform another wait for command, save, and then go ahead and close the browser. So here we can go ahead and say, right, click close. Save, there we go. And now you can see that we're back to the beginning, and if I was to slightly minimize this, what will happen is that we can go ahead and run this. So let's just save this, and let's run it, and you'll be able to see that eggplant functional will go ahead and perform the actions. Now what eggplant AI is doing is it's taking control of these snippets of code and performing actions against the system under test, waiting for eggplant functional to validate that what it can see on screen is the correct behavior, and then respond back to eggplant AI. So let's take a look at the snippets of code that supports the NASA Whirlwind application. You can see here that we have used snippets of code to perform user actions. Now we haven't created the user journey itself because Eggplant AI will manage that. All we have done is created code for the different user actions. And as these snippets of code are short, it makes it really easy for test automation engineers to maintain scripts. Now, let's go back to Eggplant AI. Up until now, we have been speaking about how Eggplant AI can automatically create test cases. In addition to this, test engineers are also able to create their own test cases and create tests for core application requirements and make sure that the application is working when those test cases run. So here let's go ahead and have a look at creating a test case. Now we would do this by utilizing the test case builder feature within Eggplant AI. The way we can do this is by clicking build a new test case, and then simply all we now need to do is click on the different actions on the model itself to perform the test case flow. So here we go ahead and click on launch app, click base camp, choose a base, click on map position, click play, monitor base, and then we end the test by stopping. And there we have a journey that we can go ahead and test. And then we can go ahead and add a new test case. And now we can go ahead and say, click launch app, go to tracks, click on positioning on the map, zoom into the specific area, click on new, apply the filters or the parameters for the new object that we're looking to push through the application, set the altitude and some of the other parameters and click OK. We can then go ahead and say draw track lines, play, monitor vehicle, and again that will then exit out. And we'll call this journey 2. So once you've gone ahead and done that, it automatically saves, and here in test cases we can see that our test cases are already ready for us to go ahead and utilize. So now let's go ahead and run them. So what we can do is we can select both of the test cases that we've created and click play, and what's going to happen here is that the AI modeling solution will go through each individual test case. So now here what we've done is we're going to go ahead and click on scenario 2, and at which point we're going to go ahead and choose the base, and we're going to go ahead and zoom in to the application. You can see that we're using the NASA Whirlwind controls to go ahead and zoom in on the application. And now you can see we're running the simulation. And what we're doing is we're picking the object that's coming towards the base perimeter being the grey circle, and objects are coming in, and we're constantly trying to understand whether the object that's flying in is a threat or not. So here we can see that several objects have come into the base's radar, and we're constantly reading them to understand what these objects are. And eventually what's going to happen is that one of these will turn to an alert, and the system's flag will then come up and show the alert actually taking place. And then we can verify that the enemy missiles that have come in, or the objects that are coming in which are a threat, to go ahead and perform the action to defend the base, as it were. And now what's going to happen is that the second scenario is also going to run, and this is where we create track lines of an application. And once the track lines have been created, again we're going to kick off the object at the beginning of the track line, and once it's gone ahead and generated the track, applied the object at the beginning of the track, we'll then go ahead and confirm that the object is moving across the track. Now we're going ahead and creating the object itself, whereby we apply the name, what kind of object it is, the speed, we're going to set the speed in meters per second, and then the altitude that that object is going to be traveling at. And now we're dragging and dropping and drawing the actual route, or the track line that the object is going to take. And now we're going to go ahead and play the actual scenario. And here you can see what's going to happen now is that as the object is moving, we'll be able to see what's actually moving, and we'll be able to record the information of the object, such as what that object is, and also how fast it's moving, how far it's actually gone, and how far it has left to go. And once it's finished monitoring, it'll go ahead and close the test case, and there you have it. So that's how we can go ahead and build test cases against the application so that we can fulfill our requirements that have come down from the projects, the different capabilities of the application, and make sure that these specific test cases, however important, have been addressed, and confirm that these test cases are working as expected. Now, another key element within Eggplant AI is coverage. This is where you get to understand how much of your application has been tested. So if we go over to the coverage report, we can see that there are several layers or several levels of coverage types. So this is everything from just checking to see if the states have been accessed, for example, all the way to full exploratory mode, going backwards and forwards between each of the individual states themselves, and all the different actions and all the different variables that can be applied at the different levels of the application, and making sure that they have been thoroughly tested, logging down every kind of bug that has taken place. And at the full exploratory level, we can see that only 8% of the application has been tested. Now, if we zoom in quickly here, we can see that the number of different paths that can possibly be taken within the application or the model itself, okay, is 1,778, and only 101 paths have been tested so far. This means that the application still has a way to go before being thoroughly tested, and given that there are over 1,700 paths that can be possible within the actual model itself, it means that you'd want to typically run this overnight. The key thing here is also understanding that in an agile world, if the application is still being developed in a continuous integration model, then typically what's going to happen is that the model will exponentially grow, and as a result, the coverage or the number of different permutations that that AI can take within the model will exponentially grow as well. But for this particular application itself, we can see that a total of 54 passes have taken place and only one fail itself. So a total pass rate of 98.18% has been achieved so far. We can also see this represented as a heat map as well. So when we go into the heat map, we can see that the bluer, the darker the hue of blue, the thoroughly tested the application is, whereas the lighter the hue of grey, the less tested the application is. So we can really get to grips and understand how well the application has been tested, how many possible different permutations there are, and based on this information we can make a decision as to whether the application is tested well enough for release. In addition to that, we can also go ahead and manipulate areas to say, well, okay, although we've tested certain areas quite rigorously, we no longer want to test those areas and we want to direct the tests in a particular way, at which point we can then start applying things like user weights around specific parts of the application. So here you can see we've actually got some user weights here where we want to test the Basecamp application side of things more so than, say, for example, the tracks or indeed the global rotation parameters.
Thank you, Pritesh. And thank you to everyone for joining us here today. If you have any questions or would like any more information, please visit us at eggplant.io. Looking forward to seeing you at the next Aerospace and Defense event.